Hello, everybody. Today we are going over the molecular bonding quiz review. We're going to have a quiz on Thursday covering the first half of molecular bonding. Anything on this review is certainly fair game for the quiz. So if you have any questions, make sure to get them asked. The first thing one thing you'll be asked to do on Thursday is to name molecular compounds. Couple things I want you to remember. We never put mono on the first element of the compound. We will always change the ending of the second element to IDE. So that's really the only two things you have to remember. It'll probably be in a Google form that you'll be doing this on Thursday. So the first one, you have 2 nitrogens. So it's dinitrogen. And there's 6 oxygens. So it's hexaoxide. If I were you, I would have these prefixes written on a sheet of paper or on your periodic table so you can easily access them on Thursday. The second one is dicarbon, and then there's 5 bromines, so it's pentabromide. You have to change the ending to IDE. The third one, there is 1 carbon. Remember, we do not put mono on the first element. Then there's 1 oxygen. We do put mono on the second element. The third one, or the fourth one, we have 4, so tetra, phosphorus, and then deca, because we have 10, iodide, and then you have trisilicon, nona, hydride, and dihydrogen monosulfide. Now, when you're writing the formulas from the names, you just have to take the prefixes and add that number of atoms to each element. So tetracarbon means 4 carbons. Decahydride means 10 hydrogens. Sulfur has no prefix, so there is 1. Dioxide means 2 oxygens. Diphosphorus would be P2. Pentachloride, Cl5. Hexabromine, Br6. Octasulfide, S8. Carbon, no prefix, so we're just going to put C. Hexahydride would be H6. And then nitrogen has no prefix, so N. Trifluoride, F3. Now, you definitely should be able to answer some multiple choice questions about ionic versus molecular bonding and the properties that exist of ionic versus molecular bonding. So remember, ionic bonding transfers electrons from one atom to the other. Molecular bonding shares electrons between atoms. Ionic bonding is between metals and non-metals. Molecular bonding is between non-metals. So that's what you should be able to answer about comparing and contrasting those two. 4 areas of negativity we've talked about. You can have a single pair being shared, which we call a single covalent bond. You could have 2 pairs being shared, which is a double bond. You could have 3 pairs being shared, which is a triple bond. And you can have just lone pairs that are not being shared, which we call lone pairs. Remember that the structural formula, two things you have to do for the structural formula. We are going to replace shared pairs of electrons with lines representing each shared pair. Now, what that means is if you have a double bond, you need 2 lines between the atoms. If you have a triple bond, you need 3 lines between the atoms. And we do not have to include lone pairs on the outer atoms, only on the central atom. So lone pairs only go on the central atom, not the outer atoms. You should know this goes back to first semester, all elements form bonds in order to get a full set of valence electrons, which for most elements is 8. But for some elements like hydrogen, they only need 2. And then boron only needs 6. So there are some exceptions to that. Now, in your lab, your ionic versus molecular compound lab, you should have looked at these various properties, and what you should have found is that ionic compounds tend to have a higher melting point. That's because ionic bonds are stronger than molecular bonds. So the ionic bonds are going to hold together longer. Covalent, I should spell correctly, valent bonds release more odor. So because covalent bonds don't hold their particles together, their particles are more likely to escape, and that's what you smell as the odor. Ionic compounds tend to be harder. So it's harder to grind up an ionic compound because the bonds are stronger. Ionic compounds are more soluble in water. So because ionic compounds are made of 2 ions that can be split apart, they tend to dissolve in water, and ionic compounds will conduct electricity. So those are the properties you should be able to identify. Now, the way the questions are going to be asked is, I'm going to give you a couple compounds and ask you which of these would give off a stronger odor, or which of these would have a higher melting point. Now, what you're going to have to do is first identify if the compound is ionic or molecular. So you need to remember, ionic compounds start with a metal. Molecular compounds start with a non-metal. So if I give you on the quiz CaCl2, you need to understand CaCl2 starts with calcium, which is a metal. Therefore, it's going to act like an ionic compound. Molecular compounds are going to be something like NCl3 because nitrogen is a nonmetal, so that's a molecular compound and will exhibit what molecular compounds exhibit. So if I asked you the question, is CaCl2 or is NCl3, which one has a higher melting point? The answer would be CaCl2 because it's ionic. Which one has a stronger odor? Well, that would be NCl3 because it's molecular with covalent bonds. And then whether it's hardness, solubility, or conductivity, calcium chloride would have the higher hardness, the higher solubility, the higher conductivity because it's ionic. All right, and then the last thing you're going to need to be able to do on the quiz is you're going to have to be able to diagram structural formulas and describe areas of negativity. So you're going to need I would have a piece of scratch paper handy. And if we're doing Cl2, we would start with 2 chlorines. So we'd put chlorine and chlorine. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Each chlorine has 1 electron. This is my central atom. You just got to pick one. So we're going to have the sharing of a single bond between these. So as we make this, I'm going to double click on the drawing. I'm going to move chlorine. I'm going to put my other chlorine. I'm going to go grab my line tool, select a line. I'm going to connect these two with a single line. And then I am going to put my lone pairs on the central atom only. So this chlorine has some lone pairs. And that's what it would look like. And we're going to save and close it. That's all I'd ask you to do on the quiz. Areas of negativity. So that left chlorine has 1 single bond, and it has 3 lone pairs. Carbon tetrachloride, CCl4. So what I would be doing is I would just sketch to myself C, and then Cl, 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 Cl. Carbon has 1, 2, 3, 4 singles. Got to circle them all. Each chlorine has 7 . So what that means is carbon is going to single bond to each of the chlorines. Like, that's all you have to do for your sketch. You're not going to show me the sketch. You're going to then go to your structural formula and you're going to go make it. And you guys are going to start to see patterns like even before you make the sketch. So we'd put carbon in the center. We would put a chlorine on each side. Good news is on this drawing is we don't need any lone pairs. So we got carbon with the 4 chlorines. We're going to go grab our line tool. I'm going to put a line here. I'm going to put a line here. Put a line here. And put a line here. And I don't care how perfect the lines are. That's it. And then we would describe around carbon, we have four single bonds. On our next example, CS2, we're just going to go sketch it real quick. So again, we already know carbon has 1, 2, 3, 4. Each sulfur has 6, which at this point, you guys should be getting pretty quick with figuring out valence electrons. We're going to get share, 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 share. So we're going to have 2 lines between each. So we're going to double click on our drawing. We're going to move carbon to the center. We're going to put a sulfur on one side. We're going to put a sulfur on the other side. Then we're going to put not 1 line between them, but we're actually going to put 2 lines because there's 2 shared pairs. And we're going to hit save and close. We're done. Then we're going to describe the areas of negative charge. Around carbon, we have 2 double bonds. Now for the next few, I'm just going to draw them. I'm the sketch, and I'm going to let you guys complete the rest. So PCl3, phosphorus has 1, 2, 3, 4, 5. Cl, Cl, Cl. So each chlorine has 1. You're going to get a single bond, a single bond, a single bond. Don't forget to put this lone pair on phosphorus. So you're going to have 3 single bonds and 1 lone pair for your areas of negativity. For boron trihydride, you're going to have boron, hydrogen, 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 single, 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 1, 2, 3. So boron is your central atom. You're going to get pair, pair, pair. So on this example, you're going to have 3 single bonds, and you're not going to have any lone pairs on boron. And your last example is OI2. So we've got oxygen, 1, 2, 3, 4, 5, 6. Iodine, 1, 2, 3, 4, 5, 6, 7. And another iodine with 7. So oxygen is my central atom. We're going to get bond and bond. Now, you have to include these 2 lone pairs on oxygen. So in this case, you have 2 single bonds and you have 2 lone pairs on your central atom. So that's how you would describe that.